Curiosity escapes Hidden Valley, explores a site named Garden City, and witnesses the Martian sunset. The rover is currently located in a valley with soft, deep and slippery sand. The team at NASA wants to get out of the valley as soon as possible, as Curiosity could become stuck. This series of images from the rear HAZ cam shows the rover backing out of the valley, retracing its tracks. This is the view from the other side of the rover, the front HAZ cam, as the team initially sent the rover in backwards, a strategy used to compensate for the poor health of Curiosity's wheels. Now safely out of Hidden Valley, Curiosity is finally approaching the Pahrump Hills. The team decides to take a drill sample at this site, known as Confidence Hills, as the rocks nearer to Mount Sharp will help to develop a picture of what happened in this area. Here is the sample in the scoop. On Sol 801, the team decides to perform an experiment by driving over a sand ripple to expose the material below. The reason for this experiment is to gain a better understanding of the loose wind deposited sand ripples in the area. Hopefully, more knowledge about these deposits will prevent future situations like the one at Hidden Valley. The wheel track provides a cross-section view of the sand deposit, and Curiosity uses its laser to take data. On Sol 817, Curiosity comes across some interesting exposed bedrock and takes a closer look. The area is about 6 feet or 2 meters across. Meanwhile, the Mars Reconnaissance Orbiter is flying overhead and spots the rover, now squarely within the Pahrump Hills area. Curiosity is ordered to perform a drill test on a target named Mojave. The result is a cracked rock. On Earth, geologists carry hammers to crack rocks. This apparent mishap presents a rare opportunity to see freshly exposed rock on the Martian surface. Curiosity is ordered to take 2 drill samples from the same site. No further cracking is observed. The rover celebrates by taking a selfie. This map shows an area named Artist's Drive, which Curiosity will have to pass to access higher rock layers on Mount Sharp. On the way, the team at NASA spots an interesting outcrop, which is named Garden City. Exposed mineral veins crisscross the entire area. Curiosity heads over to take a closer look. Mineral veins usually form where fluids move through fractured rocks, depositing minerals in the fractures. In this case, the minerals deposited in these veins have been more resistant to erosion than the surrounding host rock. The contrast between the light veins and darker rock type here suggests a very high fluid pressure. This image covers an area roughly 2 feet, or 60 centimeters across. The Mars Reconnaissance Orbiter spots the rover once again within the Artist's Drive site. Can you spot it? This interactive map, made by NASA, shows the true scale of the journey. Zooming out from the Pahrump Hills area, we can see the size of Gale Crater, as well as Mount Sharp in the center. Gale Crater is roughly 96 miles in diameter, or 154 kilometers. Curiosity stops to take a panorama within Artist's Drive, now well within the Pahrump Hills region. This mosaic shows the view in front of the rover. Gravel and sand ripples can be observed in the foreground, typical of terrains that Curiosity traverses to reach Mount Sharp from its landing site. Outcrops in the midfield are of two types: dust-covered, smooth bedrock that forms the base of the mountain, and sandstone ridges that shed boulders as they erode. Rounded buttes in the distance contains sulfate minerals, perhaps indicating a change in the availability of water when they were formed. On Sol 956, Curiosity captures multiple images of the Martians. Sunset, this short series of images, provides the most detailed view of what a sunset looks like on Mars. As Curiosity continues, it approaches an area nicknamed Logan Pass. This closer image shows that this terrain is unfavorable for the rover. Instead, the team decides to take Curiosity through a safer passage known as Mary's Pass. On its way through, Curiosity observes what scientists are calling the Stimson unit. These dark areas of finely bedded sedimentary rock are found throughout Yale crater and make up the Stimson unit. Here, the lighter colored mudstone is intersecting below the Stimson unit, leading the team to conclude that the mudstone was created first, and then a large body of water deposited minerals that make up the layers of the Stimson unit. This image of another contact zone at Mary's Pass, nicknamed Missoula, lends further credence to this theory, as the white mineral veins abruptly end where they meet the darker rock above. So firstly, the mudstone would have hardened, then fractured, and then groundwater deposited minerals to form these veins. Sometime after that, large bodies of water made the layers visible at the top. Just a few days later, on Sol 1041, Curiosity comes across another interesting rock, which is thought to have been formed by the wind and contains a large amount of silica. Rocks containing silica are known to be exceptionally good indicators of ideal conditions for preserving ancient organic material. The team at NASA orders Curiosity to examine the health of its wheels. During this process, a rock can be seen hitching a ride inside one of the wheels. The rock should prove to be no danger to the mission and will eventually fall out on its own, although showing a lot of damage as well as some rather large holes. The wheels are okay for now. The rover is ordered to take a rock sample from a site known as Black Skin and celebrates by taking yet another selfie. Curiosity explores a giant dune field, takes some stunning images, and approaches the entrance to Murray Buttes. Still squarely within the Pahrump Hills region, Curiosity finds more evidence of cross-bedding. Due to the angles of these layers, it's more likely they were created by wind rather than water. On Sol 1099, the rover looks toward its main objective. Mount Sharp, the lighter-colored rocks in the distance, are the oldest in this image and have been heavily eroded by the wind. A large portion of the other rock variations present are thought to have been formed by water. While looking for the best way to get up the mountain, the Mars Reconnaissance Orbiters spots a huge dune field. The team at NASA decides to send the rover to investigate. From its current position, Curiosity can see part of this dune field, the dark band in the mid-ground. The team at NASA gives it the informal nickname, the Bagnold Dunes, named after Ralph Bagnold, who crossed the Libyan Desert and was one of the first explorers to acquire a deep understanding of the physics behind sand dunes. In this map, we can see the true scale of the Bagnold Dunes. Curiosity will explore only a small portion of it. As the rover moves closer, it captures this stunning image, with Mount Sharp looming in the distance. But first, Curiosity has some drilling to do at a site named Big Sky. The rover takes a selfie in celebration of a successful drill. On Sol 1176, Curiosity reaches the edge of the dune field. This is the first active dune system studied up close. On another planet, scientists observing the dunes estimate they are migrating by about 1 meter per year, due to action from the Martian wind. The rover carefully dips a wheel into the sand. This close-up image of the dune portion disturbed by the wheel, shows finer grains of sand below the surface. This close-up shows an undisturbed portion of the dune. We can see that only coarse surface material remains, after wind action has removed the smaller particles. On Sol 1197, Curiosity comes across a very steep dune, which the team names Namib Dune. The thing which differentiates dunes from the usual sand deposits, such as those the rover was nearly stuck in at Hidden Valley, is the dunes are steep enough on their downward face that material can actually fall down the side of the dune. Curiosity takes a sample of sand from near the Namib Dune site and takes a selfie to celebrate. The coarse material from the sample, which was too large to fit through the rover's filter, is dumped onto the ground. The team waits until nightfall to take an image of the dumped material. With artificial lighting, this lighting makes it easier to differentiate between the darker and lighter grains. Curiosity continues the journey up the base of Mount Sharp, reaching a site known as now Cliff Plateau. On Sol 1176, Curiosity comes across some nobly textured sandstone within now Cliff Plateau. These nodules seem to be more resistant to wind exposure than the surrounding host rock. It's the first time Curiosity has come across this type of pattern in Gale Crater, but it has been spotted by previous rovers on Mars. It's likely these are what the team at NASA refers to as blueberries, and are made up of a mineral known as hematite, which suggests the presence of water in the ancient past. From its position within now Cliff Plateau, the rover takes a long-distance image of the northern rim of Gale Crater. The image is taken during sunrise, when dust in the atmosphere is relatively low. On the lower portion of the crater rim, we can see valleys, channels, and debris fans, much like what we currently see at the base of Mount Sharp. This leads scientists to expect that the entire crater was once filled with water. Curiosity takes a full circle panorama. At No Cliff Plateau, the rocks present here are dominated by thick layers of wind-blown sand, suggesting that these deposits formed during a drier time on Mars. On Sol 1315, NASA orders the rover to complete a wheel health check. Since the last wheel check nearly 300 sols ago, little further damage is observed, meaning that the rover planners are doing a great job of selecting easier terrain for Curiosity. As Curiosity comes close to completing for Earth years, on Mars it hits a milestone of 2 Martian years. Studying the planet during this time, Curiosity has been studying Martian seasonal patterns. As you can see from the graph, Mars is much colder than Los Angeles. The height of the bars represents the temperature difference between night and day. During the summertime in Gale Crater, daytime temperatures can reach a survivable -10 degrees Celsius or 14 degrees Fahrenheit. However, on the very same night, temperatures could drop all the way to -70 degrees Celsius or -90 degrees Fahrenheit. Curiosity also takes measurements of atmospheric pressure. This data will prove to be extremely useful if NASA ever wanted to send a helicopter to accompany a future rover. The rover takes a drill sample at now Cliff Plateau and looks toward Mount Sharp. We can also see some leftover rock powder, the grey substance on the surface, dumped by the rover after it did not pass through the filter. After a big drive, Curiosity arrives at the gates of a site known as Murray Buttes. Curiosity will pass through here to access higher areas of Mount Sharp.